Apis cerana japonica is a subspecies of the eastern honeybee native to Japan. It is commonly known as the Japanese honeybee, Nihon mitsubachi. This subspecies was determined, through an analysis of mitochondrial DNA, to have originally come from the Korean peninsula. They have been observed moving into urban areas in the absence of natural predators. A.C. japonica is very resistant to the mite Varroa jacobsoni, which is commonly found among A. cerana. 3-hydroxyoctanoic acid is a signaling chemical emitted by the orchid Cymbidium floribundum and recognized by Japanese honeybees. Native honeybees. Beekeepers in Japan attempted to introduce European honeybees, Apis mellifera, for the sake of their high productivity. However, European honeybees have no innate defense against Japanese giant hornets, which can rapidly destroy their colonies. Although a handful of Asian giant hornets can easily defeat the uncoordinated defenses of a honey bee colony, the Japanese honeybee, Apis cerana japonica, has an effective strategy. As a hornet enters the hive, a mob of hundreds of honeybees surrounds it in a ball, completely covering it and preventing it from reacting effectively. The bees violently vibrate their flight muscles in much the same way as they do to heat the hive. In cold conditions, this raises the temperature in the bowl to the critical temperature of 46 degrees Celsius, 115 degrees Fahrenheit. In addition, the exertions of the honeybees raise the level of carbon dioxide, CO2, in the ball. At that concentration of CO2, the honeybees can tolerate up to 50 degrees Celsius, 122 degrees Fahrenheit. But the hornet cannot survive the combination of a temperature of 46 degrees Celsius, 115 degrees Fahrenheit, and high carbon dioxide level. Some bees do die along with the intruder, much as happens when they attack other intruders with their stings. But by killing the hornet scout they prevent it from summoning reinforcements that would wipe out the entire colony. Although it is a commonly accepted theory that the Japanese giant hornet may be allowed to enter the Japanese honeybee hive, recent studies suggest that the Japanese honeybee and large hornets actually have a predator-prey ICU-ISI relationship. The ISI relationship is supported by the observation that Japanese honeybee wing beats become louder and increase in intensity as a bee-hawking wasp, such as Vespa valentina, Vespa similimazanthiptera, or Vespa mandrinia, moves closer to the entrance of the hive, and that in most cases the hornet may retreat when it hears the sound. If the hornet moves closer to the hive, the Japanese honeybees move their wings faster to intensify the warning to the wasp. If the wasp enters the nest, the bees will increase their wing movement, form a ball, and raise their body temperature. See also media related to Apis cerana japonica at Wikimedia Commons.